So suppose this is RAM. So these are the memory locations. Each of them is the memory location is a RAM. And what is unique about these memory locations is that the address of these memory locations exists in continuity. Let us assume that our array is start at some location called 19. The address is 19, and this array contains integers whose size is 4 bytes. Then 19 plus 4, which is 23, and you can jump to the next location by just adding 4 to 23 and so on. Because the address is contiguous, if you want to jump to a certain location, the nth position, you just have to multiply n minus 1 into size of each item. So you can quickly jump into nth location. So because this jump can happen with 3 or 4 steps, this is a constant time effort to jump to a location. So in an array, you can have a random iterator, which means you can access any element within a constant time. It happens as time on. When I'm saying about on, this is just the complexity, which means that if I say if that iteration is an on process, it means that the total time taken to iterate all the elements in an array will be proportional to the number of elements in an array, and the time would be n times some constant. Arrays are the data structure which are in contiguous location. If an array starts at 90, the next location can be found by adding the size of object to the starting location. So this is your array. If you want to find the minimum in this array, how would you find it? You first take an iterator. This iterator, you start the first location. So index represents position of a particular object in an array. So and index always starts with 0. Suppose if we have been given a task to find a maximum element in an array, what will be our character strategy? Our strategy would be to go to each of these elements. We update our max so far if that max so far is less than the current element. Suppose I initialize my max so far with negative infinity. Now my iterator is in location number 0. So I will see if the number is greater than max so far, which in this case it is. So I will update this number. Now I'll go to the second position. I'll see if the element in the second position is greater than max so far, which it is not, so I will not update it. Then I'll go to the third location and I will update here because it is greater. Updation also happens here. Updation also happens here. By the time we have reached this is not greater than max so far, we will not update it, and again we will not update it. We can form a similar strategy with min so far. I'll initialize with positive infinity. Notice how we are initializing the numbers. I have initialized the max so far with negative infinity and min so far with positive infinity. It is because to allow for updation, because if max so far is negative infinity, it is already at the minimum position. So any element is going to be greater than the max so far, and there is at least one updation of max so far which is guaranteed. Similarly for min so far has been initialized with infinity, so that any number which will come in the array is bound to be lesser than than this, and so there is an absolute guarantee that min will update at least once. So I'll use the similar strategy. I will iterate from the 0th location and I will find if the element is less than the min so far, and I'll update if it is. So I'll update because this is 5 is less than infinity. Then I'll go to second location. I'll find the element 4. If the 4 is less than the min so far, I'll update it. Now I'll go to third location. and I find that 8 is greater than min so far, so I'll not update it. I'll again in this case I'll not update it. Again in this Again in the case of 14 I'll not update it. 54 I'll not update it. 11 I'm not updated. But in this case, because 3 is less than, so I'll update it. So after iteration of the array, I have got the max so far or min so far. So how do you write code for such a thing? Let us first get our array. Int array is equal to, this is my array, and I will have two variables, int max so far, and I will initialize with a large number, because int min, because this is the least number. So max so far has been initialized with int min, and int min so far, another variable I'll take, it is initialized with int max. Now I'll start iteration of the array. Now iteration will happen in the index of the array. The total size of my array is 7. So my size of my array is 7. Now let's start iterating the array. How would I do the iteration? I told you, so each of the object has a given position. There is certainly the first object and there is certainly the last object. So you can iterate based upon the index of the objects. The index gives the position of the object in the array. So if the array is of size 8, the index, we have seen that the first index is 0 and the last index is size minus 1 of array. There are 8 elements and it starts with 0 and it ends with size minus 1. So to iterate, I will start with for loop. I will say int I is equal to 0. This is my index and I is less than the size of array. I will say if max so far is less than array I, the element, that ith location, max so far is equal to array I. Notice how max so far has been initialized with the minimum value, and there is at least one updation that is guaranteed. Say min so far is greater than array I. I'll update the min so far. Now we need to know if we have correctly found out min so far. So I will write max so far, and similarly we will write. Now we will see if this works, and we see that it is compiled, and we have got max is 13 and minus 2. You can see max is 13 and minus 2, and from there